Hello! Today we're going to look at calculating the standard deviation, which is a statistical measure of the spread or the variation of data. We'll get to that interpretation later, but we're going to tackle this example. So I'll give you 5 seconds just to read that, and then we'll tackle it together. Right, first thing I'm going to do is calculate the mean. So the mean we can also write as x bar. We'll come to that later. Don't worry too much about that, just now being called x bar. So mean, add all the values together, all the times in this case, 28 plus 29 plus, and so on, and the last value 30. So add all the values together and divide by the number of values, in this case number of times, and that's 6. And when you work that out, when you calculate that, it's 28.5 seconds. So the greyhound's mean time around this track is 28.5 seconds. Now to this new measure of variation, which is standard deviation. So what I'm going to do, I'm going to write out this formula, and then we're going to work it out. So we've got the square root. You've seen that before. This one you might not have seen before. It's capital sigma. This means a sum of. So sum of x minus x bar all squared all over n minus 1. Now what we're going to do first is we're going to work out the numerator. This sum of x minus x bar all squared. I'll explain what x and x bar are then. Before I forget, that's the number of pieces of data. So in this case there's 6 times, so n is going to be 6. Back to numerator. So I'm going to set up a table. And you don't have to do it this way, but this I find is the most efficient way of doing it, and leads to least errors. So we've got x bar, x minus x bar, and x minus x bar all squared. Now x is each individual bit of data. We've got 28, 29, 28, 29 again, 27, and 30. X bar, that's your mean, 28.5, so we worked out here, and I won't write that all in, but 28.5 for all of those. So x minus x bar, in this case, 28 minus 28.5, negative 0.5, 29 minus 20.5, that's positive 0.5, 28 subtract 28.5, again negative 0.5, 29 minus 28.5, positive 0.5, 27 subtract 28.5, that's negative 1.5, and finally what have we got? We've got 30 subtract 28.5, that's positive 1.5. Now in the numerator here we want the sum of x minus x bar all squared, so you've got to square these values. So I'm just going to square each of those. Negative 0.5 squared is 0.25, same for positive 0.5 squared is 0.25. In fact, these are all 0.25, or the first 4 are 0.25. 1.5 squared, that's 2.25. I should have said negative 1.5 squared. 1.5 squared, again 2.25. So we want the sum of x minus x bar all squared. So that's the sum of all these. So what we've got 1 plus 4.5, that's 5.5. So that corresponds to our numerator. So sum of x minus x bar squared is 5.5. So if I carry on up here, s, or standard deviation, is going to be the square root of 5.5 divided by, now remember n was a number of bits of data, So there are 1, 2, 3, 4, 5, 6 times. So it's 6 minus 1. So the square root of 5.5 over 5. And if you just give me a second, I will work this out on my calculator. And the answer is, to 2 decimal places, 1.05. Now the interpretation of the standard deviation is quite tricky. You can think of it as the average distance each bit of data is from the mean. It's not quite correct, though that's probably the simplest way to think about it, unless you get more deeply into statistics. I'm going to give you a way, hopefully, interpreting that might make a bit more sense. So say we call this Greyhound A, and his mean time, as we found out earlier, his or her, I should say, mean time, 28.5 seconds, and the standard deviation 1.05. Now, say we had another Greyhound, let's call it Greyhound B, and the mean time for Greyhound B was 29. If you were betting, which one would you bet on? Well, surely you'd bet on Greyhound A because it has a faster average mean time. Now, that's only if we have the information about the mean for Greyhound B. Say the standard deviation for Greyhound B was 0.5. How do we interpret that? Well, if we're comparing it with Greyhound A, smaller standard deviation, therefore it's more consistent. So it's more consistent around the mean. The times aren't as spread out, whereas Greyhound A, the times are more spread out. So if you were asked again the question, which one you bet on? Well, you still might say Greyhound A, because it's got a faster average time, faster mean time, but it's far more spread out. So far more spread out. Sorry, I just had an interruption there. Far more spread out, so it might place some doubt in your mind. Goodbye, and thanks for watching.